Hi everyone, my name is Dan, and today I'll be running the webinar on net metering versus behind the meter. I appreciate all of you joining me here today. We may still have some people kind of trickle in as we get started, but we're going to get started with things, and we're going to have some Q&A at the end as well, in case you guys think of any questions. So if anything does come up, just drop it in the chat there. We'll try and make time to get around to as many questions as possible. So today, we're going to be talking about net metering and behind the meter and how to decide between the two options. We'll talk about the pros and cons of each, the use cases, and how to decide which option is going to be the best fit for you. So to start off, we're going to talk about kind of the terms that we're going to be using today. First, time of use. So in a lot of provinces, you guys are on a rate plan called time of use. And what that is you pay a different amount for your power depending on the time of the day. So you'll notice, for example, your power is cheapest during the nighttime. It's second cheapest, usually in the evenings and mornings, and then most expensive typically during the day, around supper time. So time of use is the concept of paying different rates for the different time of the day. Net metering, the next point here, is basically the way that solar works by default in a lot of provinces. So what this is the concept that in the summertime, as we generate more power, that power goes back to the power company and you receive bill credits. These are often one-to-one. Then, of course, in the winter and nighttime, when you're not producing as much, you'll be getting that power back from your bill credits, and this allows you to eliminate your power bill even when there's not any sun. Next, behind the meter. So in some provinces here as well, including Ontario and BC especially, we've got some grants in place that allow us to get batteries and kind of gamify the system of buying power at a cheaper rate. Behind the meter allows you to store your power in the battery instead of ever sending it back to the power company, keeping it all on site and never having to worry about distribution. Which takes us to our last point, arbitrage. Arbitrage is the point of using that battery during the nighttime to charge it up at that cheapest rate. And we'll talk about different rate plans here shortly. But the idea being buying that power when your power costs the least, and then using it during the daytime when power would normally cost the most. And this translates to quite substantial savings, as we're going to see here shortly. Okay, so to start off with, we're going to talk about how metering works. So first and foremost, with your solar panels, of course, you're going to get the most amount of sunlight in the middle of the day, some in the mornings and the evenings, and not much of anything at night, of course. So we'll talk about three different scenarios here: excess power generation, partial offset, and nighttime. So excess power generation is what you'd expect to see in the summertime. For most people, you're producing about double the amount of power that you need at any given point in, say, June, July, or August. So that's where those extra credits come from. And I'll show you guys some examples here shortly. But the idea here is that with that extra power going back to the power company, when we do our quotes out, we've already made sure that that surplus is going to be enough to cover in the winter and nighttime when you're producing next to nothing. So takes us next to partial offset. So this is typically morning and evening when the sun's rising or setting. Some panels will be some power will be being produced by the panels. So you'll still get some offset, and then the credits will help supplement that to ensure that you're getting enough offset for your entire bill. And then, of course, nighttime, that's where you're going to be relying 100% on those credits. And to show you how that works, you can imagine your solar panels here. These are going to be installed usually on your roof, but sometimes on the ground. And they connect into a device called an inverter. This inverter is what makes that power usable for your home. That then connects into your home and your breaker panel and distributes the power out to all of your electronics in the house. Now, any excess power that's being generated, that's going to go to your meter. And you'll see we have what's called a bidirectional meter here. So what this is a replacement for your existing power meter with a meter that allows you to feed power both out to the grid and pull it back. This is where it allows you to generate credits. And what's really cool is you can very easily track this with something like the Solar Edge app or the GrowWatt app. But also, when you receive your power bills, you'll actually see a separate item listed for power generated as a negative number on your bill, and then power consumed as a positive number. So that way you can very easily see on every bill each month how your system is performing to offset your usage. So as that power is pushed out to the grid, that's where those bill credits are coming from. Now, the credits are one-to-one in almost every province, which means that you get exactly what you send them back. So talking about this on a more specific scale, midnight to sunrise, you're not really going to be producing a whole lot, right? And so that's when you're spending the credits. Sunrise to midday, it's a balance between spending and generating. Midday to sunset, that's when you're producing the most, not spending, exporting all of it. Sunset to midnight, going back into that nighttime, and that's when you're going to be looking at mostly using credits again. Now, if we zoom out a little bit here, we talk about how that looks over the course of a year. So, of course, as we talked about, summer is going to be your highest production. Now, for a lot of places here in Canada, a lot of people don't know this, your actual increase in usage starts to begin in March. A lot of people think, well, it's got to be June, July, or August. So March is actually the main time that people will get solar installed. And the reason why is because that is usually the first month where there's a substantial increase in generation, and conveniently, one of the lowest months of the year for most people. Because we're getting into springtime, it's more moderate temperatures, not usually really needing a whole lot of heating or cooling. So, ends up being the most convenient time, and when you start to generate credits for the coming winter. Summer comes around, that's where the bulk of it's being produced. Autumn comes around, starting to move into colder temperatures, but probably still not really using heat a whole lot. So this can also be a good time for install for some people. But usually spring is better as it gives you time to save up for the winter coming. And so that's usually how things look across the year. Now, probably you're going to start to wonder here as we talk about things, what's the benefit of using the grid versus not using the grid? So net metering uses the grid, of course. The benefit to this is that you don't need to worry about having a battery on site. Many people like to have a battery, and we'll talk about why very shortly. But for some people, they prefer to just put their trust in sending the power back to the power company and then having it sent back to them as they need it. In this sense, it can be a little bit more simple to get started with, as it does come with a smaller price tag, but the savings are there regardless of which approach we take, which takes us to behind the meter. So we'll talk about that now. So this is how power works from solar behind the meter. As you can see, the graphic looks a little bit different now. So we have power coming in through the panels into the house. Now, what's going to happen is that rather than the excess going to the grid, as you would have seen in the previous picture, it's now going into the battery instead. So during the daytime, you're relying entirely on the solar. Then during that morning and evening again, we're relying on combination of the solar and the battery. And then at nighttime, you would often rely on the battery. Now, there's a couple different situations that can arise here. If you have a smaller usage, you might be able to rely on the battery 100% and never have any real interaction with the grid. For bigger usage, it looks a little bit different, and it actually becomes a little bit more financially lucrative. So, I'll give you some examples. Let's say, for example, during the daytime, you're able to offset all your usage, but the system over the course of the year is about 20 to 30% below what it takes to offset your winter bills. So the battery, what that allows you to do is that arbitrage thing that we talked about, which if you'll recall is buying the power cheaper overnight and dispersing it during the daytime. So the battery allows you the flexibility to not only be off-grid, effectively in terms of where your power is being stored and coming from, also gives you, as we'll talk about later on some grants, also gives you the ability to buy any extra power you need back at a cheaper rate, not just if the solar is a smaller system, but also if your usage scales. So think, for example, right now you've got your house, you've got all your electronics, maybe you've got a couple kids and they're in their younger years. Well, as those kids grow up, we all know what happens, especially you have teenage girls, they're going to start using all the lights, they're going to start using all the hair dryers, they're going to start driving up your electricity bill, these sorts of things. Or maybe you see yourself getting a hot tub or an electric vehicle in the future. So this battery now is able to scale with you for that without any extra solar, which is a unique benefit to behind the meter as well. Because then as that usage scales, that battery will simply charge up automatically from 11 p.m. to 7 a.m. And then you'll be able to get that power at only 3.9 cents per kilowatt hour in a lot of places. Now we'll look at the different rates here shortly and talk about how that looks for different programs and a little bit in how it looks in multiple different provinces as well. Another battery benefit, of course, is outages. So across Canada, we've got a huge variance in terms of the reliability of the grid. For example, I personally live in Halifax. We can get outages that last 1 to 2 days. Where I grew up, only 30 minutes away from here, we had a couple major hurricanes. Power was out for 2 weeks. And I know a lot of you are hearing this and relating because of the ice storms that we had not that long ago in Ontario. right? So the battery gives you the benefit of that as well. So think, for example, usually you get a big storm, the weather's pretty crappy the day of course. What's going to happen then is your solar is not going to be producing a whole lot, power goes out, and then you're relying on the battery. So then the next day, as we all know, when a storm ends, it's usually beautiful after. All your neighbors who don't have batteries, they'll be off grid, but they also won't have power because there's nowhere for that power to be stored. But with you, with a battery, what's going to happen is the solar is going to charge that battery back up. So you can think of it kind of like an endless loop where you self-generate and power your home all by yourself without the grid until the grid's restored. So it gives you that freedom. And I'm sure soon enough, you'll have all the neighbors on the block coming down and having dinner at your place because you're the only one with the lights on. I don't know if that's what you want, but it's a nice perk, I suppose. So how does that look over the year? In the summertime, of course, there's going to be probably zero chance of having to charge that battery because think about that excess power we talked about. So of course, if you're generating a bunch of excess power, now instead of going to the grid, it goes into the battery. On the flip side, in the winter time, let's say that you're producing half of what you need during the daytime and powering your house from that, and then the battery will supplement during the morning and the evening, and then at night, it will charge up at that 3.9 cents or so per kilowatt hour. And to put that into perspective for you guys, that means that for a Tesla Powerwall, it only costs you about 52 cents to charge it. I'm sure you can agree that's a pretty stark contrast to what some of your power bills are for a day. So that allows you to kind of, even if you're not getting a lot of sun, buy your power for pennies compared to a lot of your peers. So in the spring and the autumn, lastly, what's going to happen is that you're kind of in that in-between point. As we talked about, March is usually the first month where you start to see that you're producing more power than you're using. Of course, weather can vary a lot at that time of the year. So you'll be alternating between relying on just solar and the battery and occasionally pulling from the grid. Same thing goes for the auto. And everything in between, you're 100% self-sufficient. Now, some people will opt to get a larger system or get multiple batteries for the sake of actually being independent year-round. And whether that's the right choice depends on the person, depends on the budget, depends on what the goal is for the house. So for many of you who are wondering, well, is that the right fit for me? What we can do after the fact is a lot of us will probably be getting in touch with each other and looking at individual situations for your home. So that's how we'll determine based on your needs, because here at XOLAR, we design all the systems custom to the person. So there's no one right solution. And that's why we're comparing everything together today. So to recap, benefits of being off-grid or not grid reliant, I should say, are that you have battery backup. You have the freedom to buy any excess power at only a fraction of the price. Your system is very scalable to meet any future needs that you have. Also, really neat feature for especially those of us that get poor weather is storm prediction. With Tesla Powerwall, it actually can detect impending outages. And then, of course, who doesn't want to be more separated from the government and keep all their power for themselves? So that's how that looks at a glance. Now to kind of look a little bit closer at the day, we had talked a little bit about how the power generation and storage works based on the time of the day, but I want to give you guys a little bit of a visual here. So this blue wave in the background here, this is the battery, yellow is generation, red is export to grid, and black is consumption. So I'll talk to you a bit about what that means. This is a model that I designed up based on an 18 kilowatt system with a Tesla Powerwall 3. Many of you who are looking for batteries are kind of in that same ballpark of anywhere from 12 to 18 kilowatts, usually looking at the Powerwall. So, of course, as we talked about, your consumption is going to be relatively low during the nighttime typically, unless you work night shifts, of course. And that's when, if you've got a lot of generation and your battery's already charged, you rely on that battery. If not, that's completely okay. You'll be buying that power back extremely cheap. Sunrise comes along. You see that generation spikes, in this case, about 6:37 in the morning. So this is looking at a summer day as an example. So at that point, this huge generation curve that's going into the battery, that's offsetting your consumption. And then by mid-morning, you're already putting extra power into the grid. Then late morning comes, getting into the afternoon, you're completely self-sufficient. You've got your solar coming from the solar panels. You've got your battery charged up and no reliance on the grid whatsoever. Move into the evening and into the nighttime, still getting some production as we come to sunset, relying on the battery as necessary, and if required, charging it at nighttime. Okay. So now I want to talk to you guys about some numbers behind this to put it a little bit more into, a frame of reference for your particular situation. I've chosen to use the rate schedules for Ontario, but we'll talk in a little bit of detail as well about other provinces too, just so that way you guys can get an idea of how this might look for your home. Because I know we've got a lot of people here from all across the country, so we'll look at how that looks, nationwide. Using Ontario as an example, we have two major rate plans, time of use and ultra low overnight. Now, some of you with electric vehicles are already on ultra low overnight, but most people are just on time of use, and some people don't even know that this option exists. So that's part of why I want to talk to you about it, because it offers for many people a substantial savings with a battery or even an electric vehicle. The reason why comes down to when you use your power. So these graphics here show you what rate's being charged depending on what time of day, with the legend here on the side. As you can see, most of you are spending the most on your power during the middle of the day, so 11 a.m. to 5 p.m. And then in the winters, you see that it's in the mornings and the evenings. This is where it becomes predatory, because for a lot of us here, we heat with electricity, whether it's baseboard or heat pumps. This is predatory because you're going to be getting up and having breakfast and getting ready to go about your day, and then you're coming home to cook supper, and that's when your power happens to be most expensive. Plus, it's winter, so you're heating. So that's where that brings us to the whole concept of batteries and taking us into a different rate plan. So ultra low overnight, what that is a different rate plan where you actually pay substantially cheaper at night so that you can save it up in the battery and dispense that during the daytime. So rather than a rate plan of 9.8 to 20.3 cents, you're able to now, with that battery, buy all the power that you need during the daytime at only 3.9 cents. And with the Tesla Powerwall app, and I'll show you a little example of how that's configured, the way that that works is it's configured to dispense it at usually the time the power is most expensive. So any power that you would normally be using when you're just getting home, you're making supper and driving up your heating costs because you're just all getting home, opening all the doors, cooking all the food, instead of paying peak rates for that, you're now actually only having paid 3.9 cents. This corresponds to a change of anywhere from 30 to 70% in people's power bills for that particular time frame, as the rate goes from typically anywhere from 9 to 15 cents, depending on where in here you are, all the way down to 3.9. So as you can see, lots of ways to save with that. Now, I'm going to show you guys a little bit more detail about the rate pricing for some other provinces as well. So just bear with me while I switch over the tabs. Okay. We'll actually look at some bills as well. Many of you have different looking bills, which may seem confusing because a lot of you are with the same power company, but that's just how it is, as I'm sure you guys know. So I want to talk to you a little bit about how it looks on your bill. So this is an example here of somebody who's on time of use. Now, your bill may not look exactly like this, but this will kind of give you an idea of how the payment is structured. So you'll see we've got on-peak, mid-peak, off-peak. And this is a good example because it shows the winter rates and the summer rates. So you'll see that there are 6 different rate charges depending on what time of day, what time of year. So this is kind of how you know that you're on time of use. Next, I'm going to show you tiered. So that's one that we haven't talked about yet. In many provinces, you guys have a tiered option as well. So what that means is that you're paying a different amount for power just based on the actual amount of power that you've used. So that might look like this for you. So you'll see that there's tier 1 is one rate, tier 2 is a different rate. So in this case, 9.3 cents, and in this case, 11. And then you see again, winter tier rates are of course going to be higher. That's where the power companies make the most money off of you. Now lastly, and the one of most interest to us, is ultra low overnight. So I'm going to show you what that looks like. That's the one that we talked about that gives you the ability to have your usage at the 3.9 cents per kilowatt hour, rather than having to worry about it being extremely high all the time. So, second here, a little bit of switching over difficulties. There we go. So let's take a look at this. So, as you can see, we've now got 4 rates on here. This is where it gets a little bit interesting and where it shows you how you're going to save. Notice that this person here that I've chosen has substantially more usage overnight. But even that being the case, with less than half the usage, they're paying 4 times as much at that time of the day, which is the supper time. Less than half the usage, 4 times the cost. So where the battery comes in is it takes away this. We think this is over a month, right? So if you have a 13.5 kilowatt hour battery, like the Tesla Powerwall, and you're using that every day, that's actually over the course of a month able to get rid of twice this amount of on-peak power. So imagine your bill, instead of having this $60 in this person's case, this ends up instead only being about 10. So that's where the savings kind of come from. And in this case, actually, this person's usage is low enough that it would actually take away some of their mid-peak usage too. So for a bill that looks like this, which a lot of you are in this kind of ballpark of about 200 to 250 a month, you can imagine that this would then become about 150 a month by eliminating all of the on-peak and some of the mid-peak as well. So hopefully that kind of helps with visualizing how it would impact your bill specifically. So I'm going to switch you back here to the presentation. Okay. So another couple of things I want to talk about are how the rate plans work in some of the other provinces as well. So a lot of you, we've talked about how Ontario works, but some of you are from Alberta, BC, Nova Scotia, New Brunswick. All of the provinces have some way to benefit with solar. We're all being charged increasing amounts, in many cases an increase of over 7% per year, and it can be as high as 20% depending on your region. But it's not just the increasing costs of power that are a problem. It's the fact that we have the ability to get away from it entirely. So aside from just the time of use and ultra-low overnight and stuff that we've talked about so far, some provinces have specific programs that allow you to take even further advantage. So one example of this, for those of you from Alberta, is something called the Solar Club, where you can actually specify the rate that you want to sell the power back to the company. And that can be anywhere from 8 to 30 cents. So you probably wonder, well, why wouldn't I set it as 30 all the time? The idea is you set it as 30 during the summertime when you produce extra, and set it as 8 when it's wintertime and you rely more on them. This allows you to, as silly as it sounds, actually get your power back at threefold what you actually sent them. You've sent them power at 30 cents, you get triple the amount back for the same price by sending it down to only 8 cents. So, triple the effectiveness of just normal net metering alone. Now, British Columbia, you guys are an example for a lot of you of that tiered rate that we talked about. You pay a certain amount, about 11.7 cents up to the first 1,376 kilowatt hours, which is about an average bill. But let's say you have a higher bill in the winter. Well, now they've increased your rate 30% for all successive power beyond that point. So solar brings down that usage, battery stores the extra, suddenly you're now down in the bottom rate class. So as you can see, in every province, there's always a strategy where we can kind of play the game using these programs to, even if we don't eliminate the bill, if you want to just start with a small starter system, to still gamify these programs to save by exploiting the time of the day that the power is generated, how it's stored, and when you use it. Another thing that you may find to be of use is when you do these sorts of things, you can make lifestyle changes to even further benefit. Let's say you're on ultra low overnight. Well, now, if you choose to start doing your laundry at that time too, within that time frame, now you're only paying 3.9 cents to then use your washer and dryer machine. So in conjunction with lifestyle choices, solar and a battery can allow you to take control of how much you're paying now, offset most of it or all of it, and be scalable for future usage and prepared for outages. So what happens in an outage? With solar by default, for safety reasons, of course, you don't want to be feeding power from your solar panels onto the grid at risk of somebody getting hurt. And so what ends up happening is that the solar system shuts down. For many people, they may already have a Generac system installed, or they may be content with just a small generator from Costco or something. And that's okay if that's what works for you. But there is a better way if you do want to be fully autonomous, which is the batteries. So what's going to happen is that during the daytime, of course, when the solar's hitting the panels, powering the house, powering the battery, as soon as that power goes out, your system will switch off grid within less than a second. Tesla Powerwall has the fastest transition time on the market. And for comparison, as some of you probably know from experience, that transition time for full home backup with a generator can sometimes be as much as 1.5 to 2 minutes. Imagine your power switches off and you don't even know because your clocks don't even click. That's what we're talking about here. Now, that sounds nice and all in terms of convenience, but even more importantly, for those of you who work from home, I'm sure you wouldn't want to be in the middle of something and then all of a sudden drop off. It gives you the freedom to be completely uninterrupted. So, of course, when the power's out, as we talked about earlier, relying on the battery, relying on the solar, creating a closed loop, as we see here, of solar and battery work together to keep the power. Nighttime comes, battery powers the house. Next day comes, solar powers the battery and the home, creating that endless loop of power. Now, let's recap on how the battery saves you time and money. There's really 8 main points here. So first and foremost, of course, grants. So regardless of the province you're in, there's almost always something that can be used to save money. And in provinces where, there's not grants, oftentimes you can keep an eye out for promotions we might have, and that might make it a little bit more feasible for you too. We also have really good financing options for helping people go forward with this for less than the cost of their power bills. So if you're interested in that, we could talk more about that later. For the meantime, for example, province of New Brunswick has $3,000 available for up to 10 kilowatts of solar. Manitoba is $5,000. And then in Ontario and BC, you guys have up to $5,000 for solar and up to $5,000 for batteries. By municipality, there's even sometimes some rebates for things like heat pumps. So even just in terms of those programs, there's tons of savings available to you. Now, the other thing is, of course, with alerts, we talked about this a little bit earlier, which is the pending outage alert. So with the Tesla Powerwall, for example, in the app, you'll actually get a notification if there's a brownout possibility detection. So for example, this is usually predicted based on, you'll think, for example, if you're downtown in a city, when your lights kind of dim and then get bright again, that's a sign of a brownout. That's when the grid is getting too stressed. Some of you know what I'm talking about, some of you don't, but will within the coming years as grid reliance increases across the country. But because of those little variations, the system can actually predict when there's a chance of failure of the grid and notify you so that you can switch everything into backup mode if it's not already. So you can be prepared before anybody else even knows that there's an outage coming. Also really good, again, if you work from home, because then you can call your boss and tell him you can't make it. So lots of different compatibility there. And we talked a bit about as well that 1 second to off grid. So basically what happens is normally part of the reason why it takes a while for your generator to fully kick in is when things turn off, and you probably noticed this yourselves, when the power comes back on, everything turns on. Even if it wasn't on before, somehow it's on now. TVs, whatever it is. So with the Tesla Powerwall, it's built to handle that. In fact, it can handle such a surge current from when everything comes back on that your panel would be more likely to fail than the battery. And what that means for you is that faster transition to being off-grid, which is very important because a lot of people ends up not even all turning on. You have to go out and check on the generator anyways. Where the battery is just set it and leave it. And it's like having the peace of mind of not being on the grid at all. Which takes us to independence. So not only are you independent from the grid in the sense of saving money, but the money that you are saving, you're investing that into your home. This is an asset. The solar is an asset. The battery is an asset. If you get heat pumps, that's an asset. In many cases, people will sell their home and get more value from the home than what they even invested into it in terms of renewable energy because of these increases. And so another example Many of you may not have heard of this, but there's something called the Plan to 2050, or Path to 2050, sorry. So what that is, that's a federal legislation where they're looking for every province in Canada to be on 100% renewables by the year 2050. Each province within that typically has its own provincial goals. I'll use Nova Scotia as an example because it very easily outlines what you can expect to happen in your own provinces when these goals are pushed towards. In Nova Scotia, in 2022, they wanted us to be at 75% to 80% renewable energy. We were at 43. And so what happened was the federal government fined the province. That money's not being paid for by the government, that's being paid for by us. Now, it's pretty safe to assume, as we know with politicians, that they're going to continue to not meet their promises, and that's going to continue to happen. Some of you have seen this already in sudden, abrupt 20% increases in your power bills. So you know exactly what I'm talking about. So gives you the protection against that. And the money's not going to the government for them to continue to not fix your power lines. Instead, it's going to you, to your house. Maybe you're passing your house down to your kids and they'll sell it. Maybe they're going to be able to live there, have no power bills, and be bill free. In any case, solar benefits not just you, but whoever's going to be inheriting the house, or if you sell the house, it's going to be benefiting you in terms of the sale. There's never a bad time for it because it always benefits you in the short term and the long term. Now, next thing as well, we talked about the savings, but to put that kind of into a synopsis, because of those different time of use rates, you may pay as little as 19% of your usual cost for electricity for the power that's being offset during the daytime. So what I mean is the power during supper time we talked about, for example, that you would normally be paying one rate for, you're buying that overnight for on average about 19% of what you'd be spending during the day. So imagine if you could just simply by keeping your power, save money, and then from the excess that you do need, you buy it from them when it's cheapest. I mean, that's how those of us who invest do it, right? We buy it when it's cheapest, use the money when it's most valuable, right? Same concept. Now, that translates, as we talked about, to approximately a 20% savings off of your bill over the long run, which for those of you with really high power bills, I think you'll agree is quite substantial. Now, just to kind of recap on what you can do with this battery too. So as you know, you've got the option to buy the power back. That's what's called arbitrage or peak shaving. You've got the option for backup. And I also want to show you, just briefly here, a little bit of what the app looks like, so you guys can get an idea of how that would work for you. So we're just going to switch over to YouTube here. Hopefully you guys can hear it. Okay.
The settings section houses a few important controls for Powerwall owners. Set a reserve percentage to ensure your Powerwall always has sufficient energy to support your backed up electrical loads in the event of a grid outage. Powerwall will maintain a charge level at or above your reserve unless there's an outage. The rest of its capacity will be used for daily cycling. You can also select your desired control mode. Self-powered maximizes the portion of your home's energy needs that's fulfilled by clean solar power. Excess solar energy stored in Powerwall during the day will be used to power your home after the sun goes down. This mode also minimizes your dependence on the grid. Time-based control maximizes your savings. Powerwall learns your consumption habits and automatically charges from solar and low-cost electricity from the grid to ensure that it can power your home when electricity from the grid is most expensive. Don't worry, you still produce the same amount of sustainable energy in this mode. You just send more of it to the grid for immediate use by your neighbors rather than storing more for yourself. Edit your custom rate plan to ensure your Powerwall knows when grid power is most and least expensive. Enable Stormwatch, and Powerwall will automatically prepare for upcoming weather events that are likely to cause grid outages. When Powerwall detects that an upcoming outage is likely, it fully charges and maintains a full charge until the threatening weather event has passed. Finally, If you have a Tesla vehicle that charges from Powerwall, set a threshold here to ensure that Powerwall saves enough energy for your home during an outage or when off-grid. The green percentage is the portion of Powerwall's energy that will be free to go to either your home or your vehicle. The blue percentage will be reserved for use by your home only. Once Powerwall drops to this charge level when disconnected from the grid, vehicle charging will stop to save energy for your home's critical loads.
Okay. So that actually brings me to my last point about the batteries, which is integration. So with the Tesla app, you're able to integrate everything all into one place. A lot of people who go with electric vehicles do go with Tesla. A lot of people who go with batteries for solar go with Tesla as well. Now, one that's really cool about solar is that the Tesla Powerwall has a built-in inverter in it, which you might recall from the graphic. That's the device that makes your power from your solar panels useful to your home. So the benefit to this is your solar feeds directly into the battery first, into a device called the Gateway 3. This Gateway 3 then connects into the battery. And the battery, of course, serves as your backup, your time of use, arbitrage, all that sort of thing, making everything all part of one ecosystem. Very easy to manage, very easy to track the performance of. And for those of you who constantly feel like you're just being charged whatever the government wants and it doesn't make any sense as per your actual usage, now you have a way to audit that. Nova Scotia, New Brunswick especially, a lot of us, we've seen companies getting hacked, or they can't come out to read the meter, so they just estimate it, whatever that means. Well, now you can actually see for yourself what the system is doing for you. So if there's ever any discrepancy with your bill, you've got the proof to show them what the system's doing for you. So that's everything I've got for you guys today. I'm going to take a few minutes here to answer some questions, and let's see what you guys are asking about. And then after that, we'll send out a link to my calendar as well, so that way you guys can book in a time. But let's get started with the questions here first. Okay. So first thing I see here is battery price. So the battery price, that's going to depend. A lot of people, what they opt to do because of the grants is they'll get a smaller, even just a small solar system with it. So for example, when it comes to the grants from the provincial government in Ontario, those grants apply for those who have solar and batteries. So you get the $5,000 for the solar, you get the $4,050 for a Tesla Powerwall, and they're required to be a package deal in order to get it. And that means if you get the battery, you get the solar later. There's no retroactive compensation. Point being, when combining those grants and getting them both at the same time, that substantially decreases the cost of the Powerwall by a total of about $9,000. Also varies a bit by region. So if you'd like a specific quote for your region and for your personal usage, definitely book a time into my calendar and I'll show you what that looks like for your specific home and for what your goals are as well. Okay, how many different types of batteries are there? So fundamentally, a lot of them work pretty much the same chemistry-wise. Okay, but what happens is that there's different sizes of batteries and some of them come with different features. So the main three ones we carry are the Grow Watt, the Solar Edge, and the Powerwall 3, which is Tesla. Tesla offers the lowest cost per kilowatt hour, so best value. It's kind of like buying in bulk, so to speak, in terms of battery capacity, as well as the most automation. Now for Grow Watt and Solar Edge, these are still great options and they integrate very seamlessly with the ecosystem of the solar panels themselves, but they offer a little bit less automation features. So things like the time of use might be a little bit more of a manual thing to configure rather than being as automatic and out of sight, out of mind as you would experience with the batteries from Tesla. Fundamentally, they all do the same things though. So usually the capacities for what we offer are 5 kilowatt hours, 10 kilowatt hours, and 13. And we scale that based on your goals for if you're just looking for critical loads offset, so things like your fridge and maybe a couple lights and your water pump, or if you're looking for a whole home backup. that's where we end up deciding what's going to be the best fit for not just your budget, but your actual goals as well. Hopefully that helps. Let's see if we've got some questions about solar itself. Yes. So yeah, exactly. So you're powering your home off of the solar first and foremost, and any difference that needs to be made up from the solar where it's not producing enough is made up by the battery, just like with the 3.9 cents overnight. Okay. How are the monthly fees associated with our power bills affected once you have a solar system? So this depends on your province with the distribution fees and transmission fees and delivery fees and all that sort of thing. Depends on the province. Ideally speaking, you want a battery if you want to be completely free of that. So in some provinces like Nova Scotia, for example, we don't even have distribution fees. Or some people, that actually makes up the majority of their bill, like for some people in Alberta. So it's going to very much depend on the situation. If you're somebody that has a lot of very high distribution fees, that's yet another reason to get a power wall, because then it's not going to the grid, so it's not being distributed, right? So for people who have low consumption, but seemingly still really high power bills, a lot of that, in some cases, it could be 60% of your bill is from these transmission distribution charges. In which case, of course, if you don't transmit it, it's gone. That can make a useful case too for what we talked about earlier, where you might opt to get a small solar system of only 10 panels, 5 kilowatts, and then invest more on the battery side to avoid the transmission, since that's what's making up most of your bill anyways. Okay, let's see what else. Okay, that's a good question. Do subsidies apply for triplexes with a single hydro meter? Yeah, so let's talk about how the credits are issued. So with solar, it corresponds to one specific meter. So let's say if you are in a triplex, I don't know if you own the whole thing or not, but basically what will happen is the solar will feed into the 1 meter and go to the one bill account. So if you're in a triplex with 1 meter, you probably have either some sort of lumped in cost for your power, or you split it 3 ways or something. When the power is fed to the meter, it credits the single account, which reduces the total usage for all buildings connected to that meter. So it's going to depend on your specific situation, whether you're renting, whether you own the whole thing or just the one unit, these sorts of things. So for the person asking about the triplex, again, probably book into my calendar so we can look at your specific scenario and see what that would mean for you personally, rather than just the others in the triplex. Is there a benefit or disadvantage for the batteries to be indoors or outdoors? Okay, so overall, it doesn't make a huge difference, but it does depend on the brand. So Tesla Powerwall has very efficient internal heating mechanisms, so that way, even if it's out in the cold, especially those of you out west where it's getting down to -30 and stuff, this is a very real concern. It's important for it to have heating. Now, to some extent, batteries do become a little bit less efficient when it's cold, just by the physics of how batteries work. So what a lot of people opt to do is install them in their garage, and then that way it's still connecting into the panel of the house. It would just be done through conduit, but it's in a somewhat heated area. Even if you don't have a heated garage, it's not going to be -30 in your garage if it's enclosed. So that's usually the route a lot of people will go. If you're having considerations about whether or not to put it outside or inside, that's also something we can help you with by looking at your property on Google Maps and talking to you about what your goals are, where you want the panels at, and stuff like that. So that way we can keep everything as tidy and as close together as possible. Okay, so I am going to continue to take questions here for about 10 minutes, just so you guys know. When it comes to being about 6:30 Eastern time here, we'll wrap up, and I'll be sending out an email so that you guys can book into my calendar if you do want more specialized advice and to look at how things would look like for you. But keep the questions coming for now, and I'll keep going through them with you. Typical install time for a solar system. So that's a good question. As you guys know, of course, winter's right around the corner. Generally, you don't install solar in the winter, not just because of the safety of it and there being snow and ice on the roof, but also it's kind of a ripoff if you get it installed in the winter. I'll tell you why that is. So it comes down ultimately to when you're producing that power from the solar system. So let's say, for example, if you've got 10 kilowatt system, and that's enough to offset all your usage. Your usage and production are going to follow a curve in line with the seasons, right? So in the wintertime, as we talked about, you can't expect to have as much production. And then let me show you a graph, actually. This might be a little more helpful to you. Second here. Okay, so let's take a look at that. Okay, so while the actual install on site usually only takes a couple days, the reason why we opt to install in March and February March and April, is that for most people, somewhere in this time frame is where you start producing more power than you're using. So this gray wave here in the background for this individual, they're starting with a smaller system, so they're at 70%, and then adding a battery to make up the difference with that time of use stuff. So in March here, they're still just under what they're actually using, but in April, for this person, April's the best time to install, because the black bar here, their generation, is surpassing the gray wave, which is their consumption. So usually when it comes to install timelines, yes, it's based on some things like when the government actually processes the permits, because I think we can all agree they're never in any rush for anything other than to take your money. But that is one factor. Weather's another factor. And then most importantly, we want your system to be installed right into savings. We don't want you to jump into paying a solar payment and electricity bill payment. The goal should be from day one to only have the solar system. So we take that into consideration as well. For those of you that are connecting with us right now, this is something that we're looking at for March or April. Of course, as we move toward the new year, we will be looking further out, but it's to your advantage as well, because we actually have a bunch of sales on too. So we've got up to 6,000 off solar, up to 3,000 off heat pumps, and up to 3,000 off batteries. These are stackable with the provincial rebates. So if you're considering an install for the new year, March and April is your golden time, and now's the time to book if it's something that you want to look into for the new year. Okay. Hope that answers the question. Yeah, so I see some of you are asking in the chat how to book an appointment with me. So Spencer, the sales manager here, he did post the link in the chat, but we will make sure to email it out to you all after, so that way it doesn't get buried, because we're getting quite a few messages in here. So don't worry about that. And at the end as well, actually, yeah. So Spencer, if you want to jot I guess I'll put it in here. So I will put my office number here in case any of you want to jot this down. I'm putting this in the chat right now. So you can text me at that number as well, if that's easier. I am available generally 10 to 6, Monday to Friday. But if you text me, usually able to reach me pretty much any time of the day, unless it's 3 in the morning, in which case, you're not getting a lot of solar then anyways. I'm just kidding. All right, so let's see what other questions we've got. Yes, 10 to 6 Eastern time. Okay. Yeah, so somebody said if you had a system covering 60% of your usage, would you be penalized by Hydro One on only using 40% from grid, delivery, etc.? So this is where the battery comes in. Because, of course, during the daytime, when you're using solar and you're powering your entire house from it, there's no interaction with the grid as far as that goes. It might be exported for the net metering, but in places where you do have distribution charges, you may pay distribution charges or at least taxes on the solar that gets imported, even if it's your own credits. So this is where the battery comes in as well. Where you've got the battery is that instead of pushing that power onto the grid, you keep it there. So let's say in your example of covering 60% of your offset, then you would keep your peak time during the day in the battery, and you would not pay any distribution charges on any of that 60%, like you're saying, and only the 40% you're using the grid for. On top of that, though, in that same example, think about it as you're not paying distribution charges on that 60%. Meanwhile, at the same time, you can use the battery to buy some of that extra 40% from the grid overnight to offset during the daytime. So you're actually, the situation you're describing there, Chris, that is pretty much the ideal situation for solar and battery, is to get most of the way there with solar, or all the way if you'd like, if you want scalability, and then make up the difference with the battery. How is solar capacity being calculated compared to usage like others? Okay. Well, I can show you how solar systems are scaled for sure. So let's take a look at the system here. Okay. This is this person's bills. Actually, the example I'm showing you might actually be here in the chat today. So this is how we look at it across the year. So we put in the bills for each month, kilowatt hour consumption, and it gives us a graph of how that looks over the year. So because of the way net metering works, where we're going to produce extra in the summer and produce less in the winter, what we're concerned with is building a system that across a 12-month span is going to generate at least this 24,000 if the goal is 100% offset. Okay? So that said, then when I design the system out, actually look at some design stuff too. Why not? Okay, so just do that. Okay. There we go. Okay, so basically what I'll do, this person's roof, we had a little bit limited space, which is completely okay. So this is kind of another example for a battery, right? Where you're limited in how much panels you can install. But when I'm sizing the system, see here, well, I've got 70% offset. This is based on 7,764 kilowatt hours of production. But how do I know it's going to produce that much? So our software actually allows us to see the angle. Oh, don't know what happened there. But anyways, allows us to see the actual angle that the sunlight is hitting the panels at any given time. So let's see if I can get that to. It's always the fun of doing things in real time, isn't it? Technology is great until it's not. Just a second. Because I actually get asked this question a lot, so I think it's cool to be able to show you guys. So I think that was maybe part of the problem. Okay. So now you see if I look at the panels, I can actually see the angle that the sun hits the panels at any given time of the day, any day of the year. And so you can see that, let's look at this day, for example, there's a lot of trees around this person's house. And so the sunlight's not really hitting the panels super effectively. So that's taken into consideration. Now for you, if you don't have trees around your house, maybe this is, something else on the property, maybe even if it's snow on the panels, who knows? There will be certain days that there will just not be any real production. And as you can see, that's factored in to the calculation we get for how many kilowatt hours are produced. So that's how we scale the system, is we're concerned with how much are we actually going to produce across the year versus how much you're using across the year. And then to finalize kind of that bigger picture talk, show you. That brings us back to this graph we started with. So now 70% of the year is what's being offset. These are the months where the person's completely power free. Okay, sorry about that. More tech glitches. There are months of the year anyways, usually anywhere from 3 to 6 months of the year where people are in a surplus, producing more power than they need. That extra power goes back to the power company and you receive bill credits, and we generate this number here, energy from solar, which is how much of your bill across the year is being offset. Let's say your average bill is 200, however in the summer it's 100 and in the winter it's 300, right? That describes a lot of your guys' bills right now. Then that means that in the months where it's 100, it's going to be completely eliminated. In the months where it's 300, it's going to be, still a bit high. And on average, in this case, for the 70% offset system that I've designed for this gentleman, their bill is only going to be 30% of what it was. So we're looking at it as a bigger picture, how it's going to impact you when taking into consideration your seasonal trends and your seasonal production. All right, let's see what else we've got here. I don't miss this. Yeah. So ultimately, when it comes to knowing if your system is producing more than you're consuming, with the inverters we use one of three things. So we either use the Tesla Powerwall for those of you that are going that route, or we'll sometimes use SolarEdge, or other times use Grow Watt systems. These systems come with an app. It connects to the inverter over Wi-Fi. And you're able to track your real-time data, so how much you're producing in the moment, as well as your cumulative data for how much you produced historically. Now, when you get your power bill, so let me see if I can show you a picture of that. When you get a power bill, you'll see at the top of almost all of your bills, regardless of province. There will be a spot that says your meter number, last meter read, next meter read, stuff like that, right? And then there will be a negative number. So this negative number, that's going to be how much produced. And then the positive number underneath that is going to be how much power you generated. So give me one sec, I'll show you an example. So while you can track this locally, the point is that you're able to actually see it on your bill as well to make sure that they've got it right too. Here's a good example. Oops. Image. Okay, sec here. Switch tabs to too many bills or too many tabs open. There we go. So this is what I was talking about. On your bill, in most provinces, you'll see 2 meters listed now instead of 1. One's going to be a positive, one's going to be a negative. This is how you know. If your negative number is bigger, that means that you've sent them more power. If your positive number is bigger, that means that you've taken some power beyond what you've produced and sent. So this is one way to know. The other way is in the app. Okay. I'll take one more question here as we are at the end of the hour. And then, of course, we'll be able to get in touch with you over the appointments as well. So, let's see. Yeah. So, some of you are asking about how to get approval for this sort of thing. So our process is such that we design the system for you, somebody like myself, or do the technical consulting and stuff like that. Once you decide what you're interested in, what you're not interested in, what can wait, then we choose the project, we get started with it. In the first couple weeks, that's when we're doing a home inspection, got somebody who's certified to make sure that the roof is safe to install solar on, or that the ground is not swampland if you're doing ground mount, these sorts of things, make sure that the electrical is okay and all that for the solar to be installed. Meanwhile, usually around the same time, we begin filing for your permits. We do all the permits for you. We're a turnkey company, so we do everything from start to finish. So we'll file the permits. We'll need a copy of your bill to be able to see your meter number and stuff like that to submit it to the proper authority. Usually that can take anywhere from 4 to 12 weeks. On average, I think it's about 6 to 8 to get approved. And that's what's called your net metering application. That's kind of your main point of whether or not you're allowed to export power to the grid. That gets declined, unfortunately, it could come down to an issue with your account, or it may be something that just needs revision, in terms of maybe you can't get as big a system as you want, whatever it is. In any case, we take care of getting approval from the government for getting all your permits done, and we work with you to make sure that you can get what you want installed in a way that's going to save you the most amount of money for the least amount of expense. Everything from start to finish. Okay. Well, thank you guys very much for joining me here today. It's happy that we had such a great turnout. As mentioned, my contact info will be going out here shortly to you guys. It is in the chat. If you're unable to find it, we'll send something out anyways. And I'll free up my calendar for most of next week. It'll be available for the better part of Tuesday to Friday. If you're having a hard time booking in, just send me a text or give me a call, and I'll get back to you as soon as I can. My contact info for my number will be in the email as well. So thank you guys very much. And yeah, hopefully I'll hear from you all soon. We'll probably have another one of these in a couple weeks on a different subject. So keep an eye on your emails. There will be a new link being sent out for that for people who want to join us next time. All right. Thank you very much and have a good evening.